Hello, my fellow programmers. Welcome back once more to this drives course. Today, I'm going to tell you about our mechanical device, our reducer mechanical device. What is this for? This works to increase our torque for our motor. Now, I had previously told you that a drive helps us set up our parameters. The parameters which are our variables in our motor. Now, those variables, we could be playing around with them so that we have a better control. For example, a bigger speed or a slower speed. But beware, guys, all variables are limited depending on the requirements for our system. For example, an HP drive has a limit. It has a limit for its speed. Do you agree? Generally, 1055 RPMs or other RPMs. But it depends on whether I want to modify the possible variables. It's not that I want to adjust my variables and now I have, let's say, 5,000 RPM. It's not possible. If I need more speed, then I would need to change my motor. Or in that case, since there's a lot of speed, I would change it to a servo motor. Which means that our system is always going to be limited according to our physical characteristics for our motor. So therefore, related to torque or the coupling or the pairing is limited. So many of my engineers, which are customers, they ask me this question. If I want to increase my motor torque, what should I use? Help me tune my motor so I can have, better torque. Now, I can tell you all the variables that we could have so we can compensate so that our torque increases, so that it's more efficient. But in reality, the torque as such doesn't really increase significantly. Now, for this is what we have our reducer for. And now this is my advice in case you already ran a finer tuning or a self-tuning or an auto-tuning. And even so, your motor is not available to take such a load. Then that's when you use a motor reducer, which, remember, it's a mechanical device which helps us increasing our torque. Now, these reducers that we have in this here image are very general, and there's different kinds. For example, we have our worm gear reducer, we have our gear speed reducer, and we have our planetary speed reducers, etc. It all depends on its application. That's what we're going to need, okay? Now, generally, it has an input, which is where we should pair our motor. And then it has an output, which is that which helps us generating that extra torque that we need. Now, what would happen if we use our motor with our reducer, which is our famous device, which we know as a motor reducer, which is the link between our motor and our reducer. Sometimes we say that this is a reducer, and no, this is a motor reducer. So our it's not the same thing. For this to be a motor reducer, it needs a motor and a reducer. Now, do you remember this formula? I showed it to you guys as a general formula that we use when we run some calculations, some quick calculations with our motor. And in this case, this formula is the one that we use by those reducer companies. And obviously, everything that is set on our reducer motor world. So all those engineers who already have their business, whether they're salespeople, technical engineers, they're really focused on the technical part for the company, for our reducers. They already know these formulas by heart. So I'm going to use them in this video to run our comparison between our torque and velocity. So you guys keep in mind how much it can affect to change our reducer. Now, I recommend one thing. Don't overcomplicate things when you're choosing your motor reducer. There are certain formulas to know the necessary torque and its necessary speed. So then, which motor do I need to be able to break the torque part? This is a formula that can help you out. But for the formulas, doesn't matter what you're calculating. I recommend that you speak directly with your reducer supplier so that they can check the application and that they can use the right reducer. Don't overcomplicate things. This is your bread and butter. This is their bread and butter, sorry. So they know, and they already have their own charts, actually, where they say, well, I need this application, and this is what I need to move for this much weight at a constant speed of whatever RPMs. So they already know how to select, and they know which reducer to use. In fact, they could even help you guys in choosing the motor. So pay close attention, guys. Okay, be very careful with this, and that's my advice for you, for your own benefit. Because if you make a mistake in any calculation, the reducer supplier is not going to, he's not going to take that device back because it's going to be your guys' responsibility. Unless they want to, unless you want to keep this, but it's okay. But especially in applications for much larger applications. So my recommendation, again, is talk to your supervisor, talk to your supplier. And that way, if the supplier makes a mistake, that's going to be on him. And when that happens, they should change your reducer. Okay? So you're going to save a ton of money. Okay, so please listen to my recommendation. Now, let's see on this side. I'm going to open my notepad. And let's run a drill, an exercise on how the velocity influences over torque. Torque and velocity go hand in hand. So when I decrease my speed, the torque is going to increase. So therefore, we are going to, let's write this formula. Torque equals potency over velocity or speed. Now, which variable would I need to change if I now need velocity? Well, this would only be potency over torque. Do you agree? All right, let's run a quick exercise and let's simulate some variables, okay? Now, let's suppose that I have 2.5 Newton meter torque. So for potency, I used 2 horsepower, 2 HP. And for velocity, it will be my variable that I wish to find. So if I substitute, let's go with our trusty calculator. So if I substitute these calculations or these data, it will be potency times 2 HP, that's 716, which is our constant. That's 1432, 1432. Over my torque, which is 2.5, equals 572 RPMs. So case number 1 equals 578 RPMs. Case number 2. Let's suppose that now I'm going to add this. I add torque, case 1, so torque, case 2. Now let's suppose that I'm now going to change my torque by 5 Newton meters. So again, I'm going to substitute 5 times 716 divided by 5. Oh, sorry. That's 2 times 716 divided by 5 Newton meters. What happened now? The bigger the torque, speed is going to increase. So be very careful with this, guys. At the moment when you already ran your auto tuning and you ran all of your possible changes, whether they be electrical or through our drives, or through our mechanical, which maybe we missed grease or oil, and even so, it's not giving us our enough torque, then in this case, it's time to call our motor reducer. But you should indicate it at what speed do you need the application for. Because if you don't indicate that, then it's going to affect that velocity automatically. And it's not going to be of use if we wish for a, let's say, a constant speed. If we were to decrease, and it is going to load our weight, or if it's going to run our load motion. But it would make no sense if it's slower. So you would need to be very careful. So that would basically be our relation with our torque velocity. It's the same thing if we increase our speed, it's going to decrease our torque. Now, guys, this does not happen internally in our drives. You might say, oh, well, if it's that, then I'll just change my frequency from 60 Hertz. I'm going to change it to, let's say 5 hertz. And it should be able to load, right? It doesn't actually work like that with our inverter. All we do is we modify our sinusoid waves, which is a PWM, which is a bandwidth, which is going to be modified. So all that we're doing is we're modifying the frequency, but the torque stays the same. So it doesn't work on drives. It works, but only on the physical part, but not on the external part, which is with our motor, it's speed, but we do not need that additional device or that additional external device, which in this case is our reducer. Okay? So having said this, we're basically done with this class, and I'll see you guys on our next topic. If you have any questions, run your drills, run your exercises, use the formula. Maybe you can get the potency through velocity and speed, and you'll see how much this helps you. So again, I'm on pins and needles waiting for any comments, and I'll see you on our next video.